Welcome to Mbose Educator. Mathematics Class 10, New Book, Chapter 1, Exercise 1.1, Question number 1 and 2. This is Exercise 1.1. In this exercise, total 7 problems are there, out of which 6 problems given in this page, another one given in the next page. Today we shall solve question number 1 and 2 from exercise 1.1. Question number 1 has 5 parts and question number 2 has 3 parts. So we shall solve one by one. Let's go to the next page where I have already solved. This is question number 1. Express each number as a product of its prime factors. Here 5 numbers given, we have to express these numbers as the product of their prime factors. First let us take number 1. Part number 1, it is 140. We have to express 140 as the product of the prime factors, for which we have to write solution 140. Now we shall find the prime factors of 140. So as we know, prime numbers are the prime factors by which we can divide 140. Serially I have written some of the prime numbers here. First prime number is 2, second 3, third 5, fourth 7, then 11, then 13, then 17, then 19, then 23. It will continue till infinity. So first 140 we have to see, we can divide it by 2. 2 is the first prime number. We can divide it by 2. Answer will come 70. Again 70 we can divide by 2. Because last digit is 0. 70 when we shall divide by 2, answer will come 35. 35 we can divide by 5 only. We cannot divide it by 2 and 3. 5 7s are 35. So when we shall divide 35 by 5, answer will come 7. Now 7 itself is a prime number as I have written here. So 7 we can divide by 7, answer will come 1. Now we have to write, these are the prime factors we have to write as the product of 140 because these are the prime factor of 140. Therefore 140 is equal 2 into this 2 into this 5 into 7. And finally there is a rule, we have to write these prime factors as the exponent form or power form. So 2 is 2 times, so 2 to the power 2. 5 is written here once, so it will be 1. 7 also 1 time, so 7 to the power 1. It is a rule to write the prime factors of any numbers in the power notation or exponent form. Alright, so we have solved here question number 1. Now we shall solve part number 2. So this is part number 2, 156. We shall write solution 156. Now this 156 we shall write here, and 156 is divisible by 2, so we shall divide it by 2 as 2 is the first prime number. 156 divided by 2, answer 78. Again 78 we can divide by 2, answer will come 39. And 39 we cannot divide by 2, it is divisible by 3. When we shall divide 39 by 3, answer we shall get 13. 3 1s are 3, 3 9s are 13. Now 13 is itself a prime number and we can divide it by itself only, that means by 13 only. So when 13 is divided by 13, answer will come 1. Now these the factors now which we got in the left side, they are the prime factors of 156. We shall write as the product. So 156, this 156 is equal this 2 into this 2 into this 3 into this 13. As we know, we have to write again these prime factors as the power notation or exponent form. 2 is 2 times, so 2 to the power 2. 3 is 1 time, 3 to the power 1. 13 is 1 time, 13 to the power 1. So this is the answer. Alright, so we have solved here number 2. Now we shall solve number 3. This is number 3. 3825. That means 3825. So we have to find the prime factors of this number. So solution 3825. This 3225 we shall write here. we have to check it. Can we divide it by 2? No, because last digit is not even number. Next we have to check by 3. 3 plus 8, 11 plus 2, 13 plus 5, 18. 18 is divisible by 3. That means we can divide it by 3. When you shall divide it by 3, 3 1s are 3, 3 2s are 6, 2 left, 3 22, 3 7s are 21, 1 left, 1 and 5 15, 3 5s are 15. You can divide in another place also and write the answer here. When we shall divide 3825 by 3, we shall get the answer 1275. Again 1275 we can divide it by 3, as the sum of the digits will be divisible by 3. 1 plus 3, how much? 3 plus 7, 10 plus 5, 15. 15 is divisible by 3. That means whole number 1275 we can divide by 3. So when we shall divide 1275 by 3, we shall get the answer 425. As the last digit is 5, that means we can divide it by 5. When we shall divide 425 by 5, we shall get answer 85. Now as the last digit is 5, again we can divide it by 5. 85 divided by 5, answer will come 17, and 17 itself is a prime number. We can divide it by only by 17. So 17 is divided by 17, answer 1. So we have to stop here when we got the final answer as 1. So now we have to write these are the prime factors. We have to write as the product. So see, 3825 is equal this 3 into this 3 into this 5 into this 5 into this 17. Now we have to write in the power form. 3 2 times, so 3 to the power 2, 5 also 2 times, 5 to the power 2, and 17 is 1 time, so 17 to the power 1. Alright, number third also we have done here. Now we have to solve the fourth part. This is the part number 4, 5005. So we shall write 5005 and we shall find out the prime factors of 5005. We have to write like this. 5005. We cannot divide it by 2 also, 3 also, as we have to know the rule of divisibility test. 5 1s are 5, 0 0 will be as it is, 5 1s are 5. Again 1001 is not divisible by 2 also, 3 also, 5 also. So after 5 the next prime number is 7. We have to divide it by 7. When we shall divide 1001 by 7, we shall get an answer 143. And 143 we cannot divide by 2, 3, 5, 7 also. The next prime number after 7 is 11. When we shall divide it by 11, we get an answer 13. And 13 is itself a prime number. We can divide it by 13 only. So 13 divided by 13, answer will come 1. Now we have to write as the product of these prime factors we got here. So therefore 5005 is equal 5 into this 7 into this 11 into this 13. And finally we know we have to write this all the prime factors as the power form, as 5 is 1 time, so 5 to the power 1, 7 also 1 time, 7 to the power 1, 11 is also 1 times, 11 to the power 1, 13 is also 1 time, so 13 to the power 1. And one thing remember, if all the power, there are no repetition of the numbers, means every factors have only one power. So if we shall not write this power 1, there is no any problem here. We can write this answer, this line also, no problem. We have solved here part number 4. Let's solve the last part of question number 1, that is number 5. So this is the last part, part number 5, 7429. So we shall write 7429 here, and we shall find the prime factors in this way. 7429. We have to check it. We can divide it by 2 or not. First prime number is 2. It is not divisible by 2. It is not divisible by 3 also. Next, it is not divisible by 5 also. It is not divisible by 7 also. It is not divisible by next prime number 11 also. It is not divisible by 13 also. After 13, it is the next prime number is 17. We can divide it by 17, and answer we shall get 437. And 437 we can divide again by 17. So next prime number we have to take, that is 19, and we can divide it by 19. So after dividing 437 by 19, the result will come 23. As we know, 23 is the is itself a prime number. So we have to stop here and we have to divide it by 23 only. 23 can divisible by only 23. When we shall divide 23 by 23, answer will come 1. So we have to stop now. These are the prime factors we have to write now as the product. Therefore, 4729 is equal this 17 into this 19 into this 23. And finally, we have to write as the power form or power exponent form. As we know, all the having one time only, so we can write power 1. If we shall not write the power 1 here, no problem, but better to write 17 to the power 1, 19 to the power 1 and 23 to the power 1. So here we have completed or we have solved all the problems from question number 1. Let's solve now question number 2. This is question number 2. In question number 2, asks that find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to the product of the two numbers. Here it is 3 parts given, so we shall solve one by one. Already I have solved here, just to have to understand. For time saving I have done this. So here these maths we have to solve in 2 steps. First we have to find the LCM, then HCF, and then we have to verify this formula. Alright, so let's take number 1, 26 and 91. So first of all, similarly like question number 1, we have to find out the prime factors of 26 here. So 26 we can divide it by 2. 26 divided by 2, answer will come 13, and 13 is a prime number. So we can divide it by 13 only. So 13 divided by 13, the result will come 1. Similarly, another number is the 91. So we have to find the prime factors of 91 again. 91, it is not divisible by 2 also, 3 also, 5 also. So it is divisible by 7. 7 13s are 91. And 13 is a prime number. It can divide by 13 only. So 13 divided by 13, answer 1. Now we have to write as the product. 26 is equal this 2 into 13 is equal, we have to write in the power form, 2 to the power 1 and 13 to the power 1. Next, this 91 we have to write as the power product of the power. 91 is equal this 7 into this 13. Now we shall write in the power form, that is 7 to the power 1 and 13 is one time only, so 13 to the power 1. Now let us write the LCM of 26 and 91. So LCM of 26 and 91 is, first of all we have to check which factor is common in both, and out of this factor common, the highest power we have to write. See, 13 is in both. 13 is present in 26 also, and 13 present in the prime factor of 91 also. So this 13 is common in both the number 26 and 91. So, and we shall write this 13 to the power 1. Next, after writing the common, we have to write the numbers or factors which are not common. Single numbers we shall write here. So after writing 13 in common, 13 common in both, here also, here also. So first we shall write that one. Second, which are not common, this 2 is not common, only here it's present in 26. So we shall write this 2. And another number, all the factors actually we have to check. In the second number 91, 7 is there, so we shall write it 7 here. Now all the things we have to multiply. 13 to the 26 and 26 7s are 122. So we have got the LCM here. Now we have to find out the HCF of 26 and 91. And HCF also we can find out from here only. HCF, how to find out? HCF will be the number which is common in both. The factor which is common in both only, that one will be the HCF. As we know, 13 is common in both, here also and here also. So 13 will be the HCF. Therefore, HCF of 26 and 91 is 13 to the power 1. That means equal to 13. Remember it, actually the HCF, while we are taking out the HCF, we have to see common in both and the lowest power. Common in both but the lowest power. So common in both is 13 and lowest power is also that is 1 only. It's alright. Now we have find out here LCM 182 and HCF got 13. Now we have to verify this formula that LCM into HCF is equal product of the two numbers. Let's verify. Verify LCM into HCF is equal product of the two numbers. So LCM we found here how much? 1182. In the place of LCM we shall write 182 into, as it is in the place of HCF we have to write the value of HCF 13 is equal product of two numbers. Which two numbers we took? That is 26 and 91. So we shall write 26 into 91. 182 is multiplied by 13. We shall get the result. The product we shall get 2366 equal, as it is. When we shall multiply 26 by 91, we shall get the result 2366. That means both left hand side and right hand side are equal. So hence verified the formula. Alright, we have solved the part number 1 from question number 2. Now we shall solve the part number 2 from question number 2. Let's solve it. So this is part number 2 from question number 2, 510 and 92. As first of all, we have to take 510 and we have to find out the prime factors. As we have learned from the earlier, it can be divisible by 2. 510 divided by 2, answer will come 255. Again 255 we can divide by 3. Answer will come 85. 85 we can divide by 5, answer will come 17. 17 itself is a prime number, so we can divide it by 17 itself. So answer will come 1. Similarly 92 we can divide it by 2, 46, and 46 we can divide it by 2, answer will be 23, and 23 itself is a prime number, so we have to divide it by 23. 23 divided by 23, answer will be 1. Now we have to write as the product of the factors. 510 is equal this 2 into this 3 into this 5 into this 17. Then we have to write in it in a power form: 2 to the power 1, 3 to the power 1, 5 to the power 1, and 17 to the power 1, as there is no any repetition of the prime factors. Now 92. 92 is equal this 2 into this 2 into this 23. And finally we have to write in the power form or exponent form. 2 is 2 times, so 2 to the power 2, and 23 is 1 time, so 23 to the power 1. Now let's find out the LCM. LCM of 510 and 92 is equal. First of all, which number is common in both the factors list, prime factor list? That is 2. 2 is here also, here also. But which power is highest? 2. That one we have to take, and less power one we have to leave it. We no need to write. Second, any other common number is there, common factor is there in both? No. When we shall not get any more common factor, then we have to write all other number, which is all other factors which are left out. 2 already written, then 3 is there, we have to write 3, then 5 is there, we have to write 5, and then 17, and the next number it is left out is 23. 23 we shall write here. Now we have to multiply all. 2 to the power 2 means 4 into 3 to 3, 5 are 15, and then 17 as it is, 23 as it is, and 4 into 15 product is 60, and 17 into 23 product is 391. Both when multiplied, the product will come 23,460. Alright, this is the LCM we have find out here. Now we have to find out the HCF. As we know, HCF means which number is common in both but the lowest power. See, only 2 is common in both 510 and 92. In the prime factor list, only 2 is common. 2 is here also present, it is here also. But out of these 2, which 2 we have to take? Remember it. While we are finding out the HCF, we have to take the smallest power of the common number. So smallest power is 2 to the power 1. So HCF of 510 and 92 is 2 to the power 1. It means 2. Alright. Now I have already find out the LCM here and HCF here. Now we have to verify the second step or part of the solution, that is verification. So how to verify? As we know, LCM into HCF is equal product of two numbers. So value of LCM we got here 23,460 into, in the place of HCF we shall write the value of HCF 2 equal to the product of two numbers. The product of two numbers means in the question the two numbers were given 510 and 92. So 510 into 92, product of the two numbers. Now when we shall multiply 23,460 by 2, the product is 46,920. Again 510 is multiplied with 92, the product is 46,920. Is left hand side and right hand side came same, hence it's verified. Alright, question number 2, part number 2 is solved. Now the last part of question number 2 is left, that is part number 3, 336 and 54. Similarly you have to solve. Let's solve. This is part number 3, 336 and 54. First of all, we have to find out the prime factors of 336. It can be divisible by 2. 336 divided by 2, 168. 168 we can divide by 2. Answer will be 84. 84 again can be divisible by 2. It will be 42. 42 can be divided by 2. Answer 21. 21 cannot be divided by 2. It will be divided by 3. So 21 is divisible by 3. 3 7s are 21. 7 itself a prime number, so we can divide it by 7. Result is 1. Alright. Similarly, next number is there 54. We have to find out the prime factors. 54 can be divided by 2. 27. 27 is divisible by 3. 9. 9 is divisible by 3. Answer is 3. 3 is a prime number. 3 we can divide by 3. Answer 1. Now we shall write these prime factors as their product. 336 is equal this 2 into this 2 into this 2. 1, 2, 3, 4 times. So 1, 2, 3, 4 times we have to write as the product. Remember it, multiply symbol you have to put. Into this 3 into this 7. Finally we have to write in the power form. So you see 2 is 4 times, so 2 to the power 4. Into 3 is 1 time, so 3 to the power 1, and 7 is 1 time, 7 to the power 1 we can write. Similarly 54, you see 54, 2 is 1 time, 2 into 3 into 3 into 3, 2 into 3 into 3 into 3 is equal, we have to write in the power form. 2 is 1 time, so 2 to the power 1, and 3 is 1 to 3 times, so 3 to the power 3. Now we have to find the LCM. See LCM of 336 and 54. First of all, we have to write the number, the factor which is common in both. 2 and 2 common in both, but we have to take the highest power. Highest power of 2 is 4, so we have to write 2 to the power 4 into 3 common. Another common factor is 3 in both, that is this 3 and this 3, but we have to take the highest power of the factor, common prime factor, that is 3 to the power. Here it is written given 3 to the power 1, here 3 to the power 3. So we have to take the highest power, that means 3 to the power 3. So I have taken 3 to the power 3. Then what to do? All the common numbers, 2 is common written, 3 is common written. Only one number which is not common, we have to write that one, 7 to the power 1. So 7 to the power we can write here. Now 2 to the power 4 is 16, 3 to the power 3 is 27, and 7 to the power 1 means 7. All together is multiplied, 16 and 27 multiplied, product will be 432 into 7. 432 is multiplied by 7, product is 3024. Alright, already we have find out the LCM here. Now we have to find out the HCF. As we know the HCF, what is the HCF? Similarly, we have to find out from here. Common in both, which is common in both, 2 and 4. But in HCF, we have to take the lowest power of the common prime factors here. Lowest power is 2 to the power 1. So we shall write 2 to the power 1 into another number is common in both, that is 3. But out of this 2, 3, the smallest power, one power is 3 to the power 3, another power is 3 to the power 1. But we have to take the smallest power, 3 to the power 1. Now product of 2 and 3 is 6. So here we have find out the LCM and HCF both. Now we have to verify. So this is the verification. LCM into HCF is equal product of the two numbers. LCM we got here 3024 into HCF we got 6 equal the two numbers 336 into 54. 3024 is multiplied by 6 product 18,144 and 336 into 54 product comes same, that is 18,144, hence verified. So with this we have completed all the problems from question number 1 and 2. To get all the classes regularly, please subscribe my channel. We shall meet again in the next video. Till then, thank you very much.